These are the notes for AP Calculus on the topic of integral applications of position, velocity, and acceleration. So here it says let v of t be the velocity in feet per second of an elevator at time t seconds. And the velocity of the elevator satisfies the differential equation dv dt equals this. So the derivative of velocity dv dt, that's actually acceleration. So what you're really trying to do is go from the acceleration function here with this initial condition, v of 1 equals 3 pi over 2, and get back to an expression for v in terms of t. We're sort of looking for velocity, the velocity function. So to do that, first thing we have to do here is separate our variables. So you can see here we can cross multiply and say cosine of v dv equals 3t minus 4 to the 6th dt. And now you can see the variables are already separated. The v is with dv, t is with dt. So as soon as they're separated, then you can integrate both sides. So when you integrate cosine of v, you get sine of v equals. Now this one you can use regular u substitution, or you can use the shortcut here, because what you would say u equal to is the inside function, 3t minus 4. And the derivative of that is 3. So when you integrate using the shortcut, you divide by 3, which is like multiplying by 1/3. And then you'd have, using the power rule for integration, 3t minus 4 to the 7th over 7. And then plus our unknown constant c. And then we can solve for c by using our initial condition. Our points here, instead of x and y, you can see the t is like the x, the v is like the y, so it's t, v, and the time here they give you is at time 1, the velocity equals v equals 3 pi over 2. So that's what we can substitute in. So we'll have the sine of 3 pi over 2 equals, and pull this out as a 1 over 21 out in front. And then it would be 3 times 1 for time minus 4 to the 7th plus c. Sine of 3 pi over 2 3 pi over 2 is right here. The sine is the y coordinate, which is negative 1, equals, well, 3 minus 4 gives you negative 1 to the 7th. This is an odd exponent, it's a negative 1. So this is negative 1 over 21. Plus c. And then to solve for c, you add 1 over 21 to both sides. Which would give you c equals, negative 1 is the same as negative 21 over 21, plus 1 gives you negative 20 over 21. And we can substitute that right in for c, right here. So then we'll have the sine of v equals 3t minus 4 to the 7th over 21, so 3 times the 7 right here. And we just figured out c is negative 20 over 21. And then finally, to solve for b in terms of t, we need the b by itself, so we can take the arc sine of both sides. So you take the arc sine of sine, those are inverse functions, those cancel out, gives you just v equals the arc sine, or you can write it as sine with a negative 1 there, either way. And then it's the arc sine of this whole side. You could leave it like this separate, or since they already have a common denominator, you might want to combine them, make it a little simpler to be a single fraction as 3t minus 4 to the 7th minus 20, all divided by 20. So there's our velocity function. We started with acceleration dv dt, the derivative velocity, and we got back by integrating back to velocity. If we wanted to get back to position, we could integrate again, but in order to find the c value at that time, you'd have to have a point on the position function to solve for c. Just like we had a point on velocity right here to help us solve for the constant and the velocity function. All right, let's take a look at the next example. The next one, again, gives us the velocity traveling given by this v of t. So it says, what's the average velocity of the object from 0 to 3? So whenever you're asked for the average on some interval, in this case 0 to 3, it always starts with 1 over b minus a, in this case 3 minus 0, times the integral from a to b, so 0 to 3. Whatever you're finding the average of, in this case velocity, so it'd be sine you can write it as pi over 2 times t, to make it a little simpler, and then dt. So we've got 1/3 on the outside. And again, you can use the shortcut for u substitution. So the derivative of, which you'd say u equal to, this pi over 2 times t would just be pi over 2. So you end up dividing by pi over 2, which is the same as multiplying by the reciprocal, 2 over pi. And then when you integrate sine, you get, since it starts with a c, negative cosine. You can pull the negative on the outside. Cosine of pi over 2t. And then that's evaluated from 0 to 3. Again, since we're using the shortcut, we don't change the lower and upper limits. We just leave them 0 to 3 because we're keeping it in terms of t. So now on the outside, this simplifies to be negative 2 over 3 pi. And then when you substitute in 3, you get cosine of 3 pi over 2. Minus, when you substitute in 0, that wipes everything out inside there, so it just becomes cosine of 0. So if we draw our unit circle here, 0 is right here, 3 pi over 2 is right here. So cosine of 3 pi over 2, cosine of the x-coordinate is 0. So that one's 0. Minus cosine of 0, right here. Again, cosine is the x-coordinate, which is 1. So this is 0 minus 1 in here. So that's a negative 1 times negative 2 over 3 pi equals positive 2 over 3 pi. And here, notice we're not giving any units for time. So this could be, since it's velocity, units per second, units per minute, units per hour. We don't know what the units for time are, so we'll leave that off in this case. Now, this next one asks for the average acceleration on the same interval 0 to 3. So you start off the same way, 1 over 3 minus 0. integral from 0 to 3, but this time we want the average acceleration, so rather than velocity being here, you would put acceleration, a of t, or you could write it as v prime of t if you want, because acceleration is the derivative of velocity. So there's a couple ways you can do this. The longer route would be to actually find the derivative here, not that hard, using the chain rule, and then integrate that, just like we did here. But the easier way, the more efficient way, is to realize, well, when you integrate acceleration, you just get back velocity. Oops. Because we've already integrated it here. This will become from 0 to 3. We integrate acceleration, we get back velocity v of t, which we already have right here. So there's no need to actually figure out acceleration in this case, unless you just want to, because when you integrate it, it gets you back to velocity, which we already have anyway. So then we've got 1/3 on the outside. And then when you substitute 3 into velocity, that becomes the sine of 3 pi over 2 minus, when you substitute in 0, the sine of 0. And the sine of 3 pi over 2, we've already drawn here, you can see it's -1. Minus sine of 0, you can see there's a y-coordinate 0. So that's -1 times 1/3 gives you -1/3. And again, we don't have the units for time here. So this would be units per second squared, units per minute squared, units per hour squared, we don't know. So we just leave it -1/3. All right, let's take a look at the next example. So this one says we've got a particle moving along the y-axis, and again we're given velocity, v of t, and it says the particle is at position y equals 5 at time 2. What's the position of the particle at time 4? So we're trying to find, usually they would call the position function, since it's moving on the y-axis, y of t. So that'll give us some notation to use here. So we're trying to find the position at time 4. So we're looking for what's y of 4 equal to. And since we have one point on position, and we also have its derivative, which is velocity, whenever you have one point on a function and you have its derivative, and you're looking for another point on the function, that's when you can set up as an initial plus change problem. So the initial one here we're given is we know the position at time 2 plus the change comes from the integral, and we want to know how much does it change from this time to this time, so from 2 to 4. And then what we integrate is the derivative of position, which was velocity. In this case, we know that's 3t squared plus 8t. And then y of 2, we know right here is 5. The position at time 2 is 5, so we can put in 5. Plus, now we can integrate this side, over here. So we've got 3t cubed over 3 plus 8t squared over 2. Evaluated from 2 to 4. And let's keep writing the 5 so we don't forget about the initial. Plus, you can simplify this a little bit before you substitute in. So you can see that 3's reduced out here. And 2 goes into 8 4 times. So this really just simplifies to be t cubed plus 4t squared. So we get 5 plus and you can substitute in the 4 first. So 4 cubed gives you 64 plus 4 squared times another 4, that's really like another 4 cubed, so that's another 64, minus, when you substitute in 2, 2 cubed is 8, plus 2 squared is 4 times 4 is 16. So we have 5 plus 64 plus 64 is 128, minus 8 plus 16 is 24. So you get 104 plus 5 gives you 109. Okay. And again, we're not given, well, in this case, it'd just be units position. Since it's moving on the y-axis, that's where it is, 109 units on the y-axis. All right, this next one's similar, except this time we're given, it's moving along the x-axis, and its acceleration is given by a of t. And we're asked, or we're told the velocity is 6 at time 0. What's the velocity at time 3? So usually we use v of t for velocity, so we're trying to find what's the velocity at time 3. We know the velocity at time 0, so that's our initial. And we can set it up as another initial plus change. Because we also have the derivative velocity here, acceleration. And the change this time would be from the time we know the initial is at 0 to the time we're looking for velocity 3. I want to know how much is the velocity change on the interval from 0 to 3. And derivative velocity is acceleration, which we have is sine of pi. Again, I'm going to write it as pi over 4 times t. So a little easier to see how we can integrate that. So now, the initial, so we have v of 3 is v of 0, which is 6, the velocity, that's our initial time. Initial velocity at time 0, plus, again, we can use the shortcut for u substitution. You would set u equal to pi over 4t. The derivative of that is pi over 4, so using the shortcut, we divide by pi over 4, which is the same as multiplying by 4 over pi. And then, when you integrate sine, it's negative cosine. So the negative can go out here and turn that into a minus instead of a plus. And cosine of pi over 4t, function of side stays the same, from 0 to 3. So we have 6 minus 4 over pi. And then we'll substitute the 3, so it becomes cosine of 3 pi over 4 minus, when you substitute 0, wipes everything out inside the cosine, so cosine of 0. So let's draw our unit circle over here. There's 0, cosine of 0 is 1. So you have 6 minus 4 over pi. Cosine of 3 pi over 4. Well, 3 pi over 4 is in the second quadrant. This is pi, which is 4 pi over 4, so 3 pi over 4 is right there. Cosine is adjacent over hypotenuse. So it'd be negative 1 over root 2, which simplifies to be negative root 2 over 2. Minus, we saw cosine of 0 is 1. So if this was free response, you could stop right here once you get down to pure numbers. You don't have to simplify further for your response, we could stop there. However, if it was multiple choice, they might simplify a little further by distributing it out, this -4 over pi. So if we did distribute that out, we get 6. The negatives cancel here, so it would be plus. And then the 2 goes into the 4 twice, so it'd be left with 2. And the root 2 is still there, over the pi is still there. And again, the negatives cancel out here, it gives you plus 4 over pi. You could combine these to be a single fraction also, or leave them separate. And again, we aren't giving any units for time here, so it's velocity, it could be units per second, units per minute, we don't know, so we'll leave off the units in this case. And that concludes the notes for AP Calculus on the topic of integral applications of position, velocity, and acceleration.